Okay, so hopefully you had a chance to look at these different graphs and try to match them. All right, so we're now in a new section. This is section 3.4. All right. And so um I can't write the whole thing on here on the whole page, so I'll just do this by parts. So the first one here for the first one, the greatest integer function, you should have written down. Second here, let me put this. Okay, you should have written down f, and the equation for that is something like that. Sometimes it's f of x is equal to int and x. Okay. For the second one here is the constant function, and the answer to that is capital I, and f of x is equal to b. All right, that's just a horizontal line. The third one is the cube root function, so the answer for that is capital H, and f of x is equal to the cubic root of x. The next one is the absolute value function. The answer to that is a, and the um, standard equation for that is the absolute value of x. All right, so those are the first four there. So we're gonna have to erase that and move on to the next one here. Okay, so the next four. Okay, we have the linear function. Okay, so the linear function, the answer to that is g. Okay, and the equation for that is f of x equals mx plus b, which we have been talking about. Okay, the square root function, the answer to that is d. And again, that's just f of x equals the square root of x. The next one is the reciprocal function. The answer to that is e, and that can be written as f of x is equal to 1 over x. The quadratic function is b, and that can be written as f of x equals x squared. Sometimes, again, that can be written as ax squared plus bx plus c. And then for the last one here, it says the cube function. Okay, so the cube function is capital C, and then f of x is equal to x to the third power. Okay, so it's really important, vital to memorize these graphs, and understand them because it will help you a lot on the exam. Okay, so understanding that a square root of x looks like someone taking a field goal, or y equals mx plus b is equal to line, right? Graphing a line. It's really, really helpful to understand what the graphs look like with the equation. Okay. All right. Any questions on this part? All right. All right, so this section is talking about piecewise defined functions. So piecewise meaning that you have multiple equations and you put them together to form a bigger, or I should say multiple parts of a graph, and you get a bigger graph. Okay? So here you have three different uh, equations. You have f of x is equal to negative x squared plus 4, f of x equals to 4, and f of x equals negative x plus 5, right? So that's why it's called piecewise. You're um, putting those pieces together. And the other part of it is called defined, and that's important. And what that means is on the right side of this is saying if negative 3 to 0, if 0 to 3, and if x is greater or equal to 3. So that means it's only defined, or you can only graph those particular equations in these intervals. That's what it's saying. Okay. So let's go ahead and plot these. That's working, okay? And see what happens here. All right. So, all right, so here's the red dot. And what it's going to do is it's going to map or only graph the portion from -3 to 0. So here's the first part of the graph. Okay. Then it'll jump to the second part of the graph and it'll only graph it from 0 to 3. Then it'll jump to the next one. And that will go from -3 to infinity because it's an arrow saying it goes on forever. Okay. So this is a example of a piecewise defined function or graph. And believe it or not, this is also very difficult for students um, to do. Okay. And part of the reason I believe is not understanding where which graph to use at which interval. Okay. So let me pause here for a second. Look at this. Okay, so this example, again, this is a piecewise defined function example. And all they want us to do is figure out, okay, which equation we're going to use and evaluate it at those particular points. Okay, so when you see the first part here, okay, so the first part here is saying that x is less than 0, right? So that means it's going to be at the left of 0. Okay, so left of 0, right? This one that says at x equals 0, that means it's going to be at 0. And this one says x is greater than, so it's going to be at the right of it. Okay, all right. So let's look at the first one. We want f of -2. So -2, is that going to be less than 0, at 0, or greater than 0? At the left of that, at 0, or at the right? Good, right? It's going to be at the left. So that means then for this case, we want to use the first equation, right? Because again, it wants us to evaluate only at the left of 0 because -2 is less than 0, correct? Right? So that means I'm going to have f of x is equal to x squared. Or in this case, I have f of -2 is equal to -2 squared, which gives us a +4. And that's it. That's our answer. Okay. All right. Let's do the next one. All right. This one is f of 0. Is that going to be the first, the second, or the third equation we're going to use for that one? Second. Good. Right? It's going to be the second. So in this case, we're going to have f of x is equal to 2. And we're going to plug in 0, right? Because it says when x is equal to 2, or in this case, at 0. All right? At 0. So I'm going to plug in 0 for x. Well, there's nothing to plug in because there is no x in here. So the answer is just 2. So no matter what value you put in for x, it's always going to be 2 because it's a horizontal line, right? Give me any x value, it's just going to be always y is equal to 2. Okay. All right. And then the last one here is f of 2. So which one would I use for that one? The first, second, or third? Third. Good, right? Because again, 2 is bigger than 0, right? 2 is bigger than 0, so that means I have to use that last one. So I have f of x is equal to 2x plus 1. Then I plug in 2 in for x. Okay? So that gives me 2 times 2 is 4 plus 1, which gives me 5. And that's it. That's all I have to do here. Okay? But again, students make it more complicated than it is. But that's all I have to do. Find out where does these points lie, which one do I pick, the first or second or third graph, and then evaluate it at those particular points. That's it. Okay? Question on that one? Okay? Okay. All right, so why don't you guys try one? Let me pause this here. Okay, so let's go through here. All right. Okay, so again, we need to figure out which equation do we use for each of these input values. All right. So the first one we have f of 0. Right? So f of 0 is going to be between -1 and 2, right? -1 and 2 is going to be between 0 and 0 is going to be between -1 and 2. So that means then I'm going to use the first equation for I'm going to use the first equation for a. So this is going to be f of x is equal to 2x minus 4, and we want 0. Okay, so that'd be 2 times 0 minus 4. So that's going to give us -4. All right. For part B, we do the same thing. 1 is still between -1 and 2. So we're going to use still the first equation. So this was A. So part B, we're going to have f of x is equal to 2x minus 4. And then we're going to evaluate that at 1. So 2 times 1 minus 4. So that's going to be 2 minus 4, which is -2. Okay. For C, all right, C here, we have 2. But we have to be careful because it says between 2 and 3, but there's no equal sign. That means that we can't include 2. But here, it does have an equal sign. So that means we have to pick the first equation again for that one. So that's going to be, again, f of x is equal to 2x minus 4. And then f of 2 is equal to 2 times 2 minus 4, which gives us 4 minus 4, which is 0. And then the last one here, okay, it says f of 3. Well, 3 is right here, right? It's between 2 and 3. So, and the endpoint there is included because there is an equal sign. So this is going to be, so I'm going to put 3 here. So I'm going to use the last equation. So f of x is equal to x cubed minus 2. So when I plug in 3 there, so 3 to the third minus 2. So that's going to give us 3 times 3 times 3 is going to give us 27 minus 2, which is 25. Okay, so those are our answers there. Okay, so this next part I'm just going to refresh your memory on graphing. So remember we have y, let me use a different color here, stand out. We have y is equal to mx plus b, okay? So b here is your starting point, and m is your slope, right? And remember that's just rise over run, okay? So you always want to start at b and then you go rise over run. Okay, so in this case, we have y is equal to 2/3 x plus 1. So in this case, again, I want to start at 1, right? So I'm going to plot that point there. Okay, then I have 2 over 3. So that means I'm just going to go up 2. So 1, 2, and then over 3. 1, 2, 3, right? And then I just draw my line. And there's my graph. Okay, let's do the second one here. I have y equals 1/2 x minus 3. So again, I'm going to start at -3. So that means I'm going to go down. Excuse me. 1, 2, 3. Plot your point. Then I go up 1. So I go up 1, then over 3. 1, 2, 3. Okay. And then there's my graph. Okay. All right. So let's try this one here. Okay. This one says we have y is equal to -3x minus 1. Well, again, I'm going to start at -1. So I'm going to go down 1, put my point there. Then this one doesn't have a number in the denominator, so I'm just going to put a 1 over it. -3 over 1 is the same thing as -3. So then that means I'm going to go down 3, 1, 2, 3, and then over 1. And then there's our answer right there. Okay. All right. Okay, so why don't you guys try this one here, number 6. See what you get. Okay. All right. So hopefully you had a chance to attempt this one, right? So we got +3. So we're going to start there. So we're going to go up 3, 1, 2, 3. Okay, we plot our point there. Now this negative here, this negative in the front, I can either put that on the top, so it could be -3 over 2, or I can put on the bottom as 3 over -2. I kind of want to get it over with, so I just put it on the top. Okay, so in this case, I'm going to go down 3, 1, 2, 3, and then over 2, 1, 2. Okay, and then there's our graph there. Now, to be sure that you did graph it correctly, this is a negative slope, right? -3/2 is a negative slope, and this is a negative slope that we have, right? So this is negative. These are positive, right? Anything pointing to the right are positive. Anything pointing to the left are negative. So you want to make sure that you do match them, okay? What about this one, number 9? Where do we start there? Where is that going to start? 0. Yes, perfect. Okay, so there's nothing there, so we're going to start at 0. So I'm going to put a point there, then we're going to go up 5 over 3. So 1, 2, 3, 4, oops, sorry. 1, 2, 3, 4, 5, and over 3. 1, 2, 3. Okay, and then there's our graph. So it's a graph going through the origin. Right, so remember this is the origin there. All right, questions on that one? Okay. All right, so let's look at the next part. So these ones are nice because everything is set as y equals, right? So what if we don't have that? So that we have something like this. So let's look at the first one here is -3x plus 2y equals 2. So what I need to do is I need to solve for y first, and then I can graph it. So we have -3x plus 2y equals 2. Right? So we're going to add 3x to both sides. And then this cancels, and we have 2y equals, and I like to put the x in the front because I want it in the form of y is equal to mx plus b. Okay, so then I have 3x plus 2, then I divide everything by 2. Okay, so then we have y is equal to 3/2 x, and 2 over 2 is 1. Now you want to put this, I know it's tempting to write it as a decimal, but since we're graphing, you want to write it as a fraction form. Okay. All right. So again, then the rest is the same. Okay. So we're going to go up 1. Okay. Then up 3. 1, 2, 3. Then over 2. 1, 2. Okay. And then there's our answer right there. Right. So we have a positive slope and we have a positive slope. Okay. All right. Question on that. Okay. So why don't you guys try one? Why don't you try this one here, number 8? See what you get there. Okay. So, oops. All right, so again, hopefully you got this. So we're going to start with 2x minus 2y plus 5 equals 0, correct? So then we want to write this in y equals mx plus b. So we're going to subtract 2x on both sides. All right, so then the 2x cancel, leaving us with -2y is equal to, again, I like to put the x in the front. So negative 2x plus 5. Then we're going to divide everything by negative 2. Okay. So then y is equal to negative 2 divided by negative 2 is just a positive 1x. And then we have a minus 5 over 2. Okay. That negative is going to trump that positive. All right. So then we just graph this. So 5 over 2 is just 2.5, isn't it? So we're going to go down negative 2.5. So it's going to be here's 1, 2, 3. So I just want half of that. So that's negative 2.5. Then this one here, I'm going to write as 1 over 1. So I'm going to go up 1 over 1. Okay, so I went up 1 over 1. I know it's kind of hard to see, but then there is our graph there. Okay. All right. Let's do one more here. All right, so let's try that last one there. See what you get. Okay, so when we solve for this one here, right? So we get y minus 3 equals 0. So we're going to add 3 to both sides. So that gives us y equals 3. What kind of graph is that? Anybody remember? It's not just a point. Yes, it's going to be a horizontal line, right? If it's x equals 3, then it'll be a vertical line. And if it's y equals 3, it'll be a horizontal line. So that means any x value you give me, right? 1, 2, 3, here's 3 here. It's just going to be a horizontal line across, right? So this is y equals 3. Okay, so any point you give me, any x value is always going to spit out y equals 3. Now, if we had, say, x is equal to 2, then it would be a vertical line going up and down. Okay, all right? So it just depends on the context. If they're talking about the graph, that's what it will look like. If they're talking about the point, then it will just be a point. All right, but in this case, they're looking for a graph, so it's going to be either the horizontal or the up and down there. All right, any questions on graphing here? So let's look at this next part. So here they want us to graph the function. So we have negative 2x plus 3. So let me write that. I know that's a little bit fuzzy. So let me write that down. So we have y is equal to negative 2x plus 3. And the other one is we have y is equal to 3x minus 2. Okay. So what it wants us to do is it wants us to graph these. And so how do we do that? So let's look at the first one. We have negative 2x plus 3. So again, we're going to do what? We're going to go up 3, right? So why don't you guys try it first? See what you get. All right, so the key number here is 1, right? Because that's when things are going to change. So I have y equal to negative 2x plus 3. So I'm going to plot the 3 first. So I'm going to go up 3, 1, 2, 3, put a dot there. Then we're going to do negative 2 over 1. So we're going to go down 2, 1, 2, and then over 1. All right. Now I have to be careful here because it says is x is less than 1. So that means I only want the graph that's going this direction. I only want the graph that's on the left side of 1. And it also means there's no equal sign. So that means that 1, right, I'm going to have an open circle. Right? So it's going to be an open circle. Okay. So again, I went up 3, 1, 2, 3, and then down 2 and over 1. So then my graph is going to look something like that. Oops. Try that again. All right. So hopefully you wrote that. Okay. So that's what we got for this one. So again, this is this part there. Okay. Now, let's look at the second part. So the second part says, okay, we want 3x minus 2 is greater than or equal to 1. So again, 1 is our critical point here. So they're going to go down 2. So 1, 2, put a dot there. Then it says, okay, 3 over 1. So we're going to go up 3. 1, 2, 3, and then over 1. So hey, we landed there again, right? But in this case, it says greater than or equal to 1. So that means we need to fill in this dot. Because again, this is a function. We can't have an open hole. So then, and we only want what? We only want it to the right of that. So that means anything going this direction, right? So we don't do anything here, okay? Because he only wants greater than or equal to, that means to the right of 1. And this one's saying to the left, okay? Hopefully that is not too confusing. All right, we are running out of time here, so let's go to the next part. Okay, so this one is graph the function. We have 1 plus x is less than 0, and then we have f(x) equals x is greater f of x is equal to x squared, which is if x is greater than or equal to 0. All right, so we'll go ahead and give you a minute or so to draw this. Again, if we don't remember what a graph looks like, we can always draw a x and y table, right? So if you don't remember what an x squared looks like, just draw an x and y table, and you just pick points, right? So -2, -1, 0, 1, 2, right? So you just plug in those points and see what you get. So I like to pick points around 0 because that gives me an idea what the left side of the graph looks like and on the right side. Okay, so if we're focused on the XY here, we know it's a parabola, right? But we don't really know where it lands on this graph. So again, we need some points. So we have the -2 square, which will be 4, -1 square, which is 1, 0 square is 1, 1 square is 1, and 2 square is 4. So that means we get the point -2, 4, -1, 1, oh, so that should be a 0. 0, 0, and then 1, 1, and then 2, 4. Okay, so those are our points. So now, but we don't have to plot everything because it says we want greater than or equal to 0. So here's 0. We just want everything from the right of 0. That's what it's saying. I don't care anything about the left. I just want the right of 0. All right, so the right of 0, that means it's going to be these points here. So we got 0, 0, we got 1, 1, and then we have 2, 4. Okay, so that's going to be our parabola. And again, at 0, we have greater than or equal to, so that means this is going to be filled in, and then something like that. Okay, now for this one here, okay, so we have this one that's going to be y is equal to x plus 1. I like to, again, like to have that variable in the front. So we're going to go up 1, okay, and then we're going to go that if there's nothing in front of the x, I just automatically 1 and over 1. So we're going to go up 1 over 1. Okay, so up 1 over 1. All right, so in this case, it wants us to, okay, so up 1 over, okay, yeah. So in this case, it just wants us to graph what's less than 0. So again, here's 0. So anything less than 0. But at 0, we have an open circle. So that means I need to put a open circle there. So again, this is y is equal to x plus 1. And then we're going to go so up 1 over 1. So it's going to be something like that. Okay, so that is our graph. All right. So that's all they want from there. Okay, we have one more problem here and we'll be done. Okay, so the last one is a word problem. And it says, let me pause this here. It says, Sprint PCS offers a monthly salary plan for $39.99, includes 450 minutes, anytime minutes, and charges 45 cents per minute. The following function is used to compute the monthly cost for a subscriber, where X is the number of anytime minutes used. Compute the monthly cost of the phone for use of the following number of anytime minutes. Okay, so this is pretty straightforward. So it's basically application of what we've been doing. So we want let me use a different color here. We want A is 200. So 200 is going to be between 0 and 450. So we want to choose this one here, right? 200 is going to be between 0 and 2 and 450. So that means then for A, our answer is just going to be 39.99. Okay, so I'm going through this pretty fast. I'm basically out of time here. Okay. And then the 465, well, that's going to be here, right? Because that's greater than 450. 465 is greater than 450. So I'll put 465 here. And that means we're going to use this equation. So we're going to have y is equal to 0.45x minus 162.51. Then we're going to plug in 465 for x. Okay. All right, so when we do that, we get $46 and 74 cents. And then the last one here is we want 451, right? So y is equal to 0.45x minus 162.51. And we want 451. So we're gonna plug that in for x. So we're going to have 0.45 times 451 minus 162.5. So when we do that, we get $40.49. Okay. All right. Any questions there?